Hi everyone. Today we learn about working principle of transformer. Let's get started.
What do you know about transformer? It's not transformer the robot, okay? It is there are two types of transformer. First is step down transformer, usually used in mobile phone charger. The second one is step up transformer, for example used in microwave oven. This is the structure of transformer. It have AC power supply, limited soft iron core, leakage of magnetic flux, output terminals, secondary coils, number of turns, magnetic field lines, primary coil, and number of turns. For there are two circuits in transformer. Firstly, the primary circuit. AC power supply produces an alternating current in the primary coil. The alternating current produces a magnetic field that changes in magnitude and direction. For the secondary circuit, the changing magnetic field induces an alternating voltage across the secondary coil. The formula for secondary circuit is Vs over Vp equal to Ns over Np. For primary and secondary circuit, both have both their magnetic flux from the primary coil is linked to the secondary coil through the soft iron core. Next, we will proceed with simulation of transformer. Before that, let's learn a bit. How is high voltage from a unity pole converted into low voltage for a home? Ah, let's learn about this. Modern electrical grids run on alternating current, also known as AC. This means that the direction of the current running in the wire as well as the electric potential voltage swing back and forth 50 or 16 times per. The voltage is very high on a residential power line, measured in thousands of volts. This helps with efficiency of transmission of power. Appliances in your home require much lower voltage, typically between 100 and 200 voltage. How do we step down the voltage? Let's look at the physics behind this. A transformer on your utility pole can step down the AC voltage. A transformer is a magnetic device consisting of an iron core and two loops of wire. One loop of wire is attached to the high voltage end. We call this the primary. The number of windings determine the amount of magnetic flux in the core. A second loop of wire is attached at the low voltage end. We call this the secondary. The number of secondary windings determine the amount of magnetic induction in the second loop. An alternating magnetic field induces an alternating current in a second loop of wire, even if they are not in direct electrical contact. If the high voltage end doesn't oscillate, no induction occurs. So, let's go to the simulation of what we have learned just now. You can try this simulation. Firstly, let's take a look at the slider. Firstly is the switch. The switch allows you to change the type of input voltage from alternating current AC to direct current DC. In order for magnetic induction to proceed, the magnetic field in the transformer needs to be changing with time. So only an alternating current will allow the transformer to do its job. The next one is primary voltage. This slider controls the input voltage to the system, presumably from some outside source like a power line. For alternating current system, this is the peak voltage. The next one is primary winding. Ah, this is this is the one that controls the number of times the input primary wire is wrapped around the magnetic core. More winding means more magnetic flux in the core and more magnetic induction at the output secondary side. The fourth one is secondary winding. The slider controls the number of times the output secondary wire is wrapped around the magnetic core. More windings mean more magnetic induction in the secondary circuit from a given alternating magnetic field in the iron core. Next, let's take a look at the graph above. The graph is about the primary voltage and time in milliseconds, and also about secondary voltage and time. This represents the situation in which the power grid, the electricity went from power grid to transformer and to our residential appliance. That's all for our lesson. I hope you learned a lot from this video. Thank you for listening. Hi everyone.